Hello, and welcome to the presentation for our paper titled ECONet, Efficient Convolutional Online Likelihood Network for Scribble-based Interactive Segmentation. As we are all aware, COVID-19 has had huge impact on millions of lives around the world. In clinics, CT volumes from COVID-19 patients have been used to study the extent of lung damage, assess disease progression, as well as make relevant treatment plans. This data is quite useful for training deep learning models. However, training such models require manual annotation of the data, which is often time consuming and requires expert knowledge. Lung lesions in CT volume suffer from appearance ambiguity, where some of the lesions may appear similar to non-lesion regions. In addition, characteristics of lesions may vary between patients and depending on the underlying condition. Existing interactive segmentation methods solve the efficient annotation problem by either relying on appearance-based features in an online setting or looking at CNN features with fine-tuning in an offline setting. In our case, we want to address an online learning problem, but also learn deep features so we can look at solving the appearance ambiguity. More specifically, we want to answer the research question, can an online interactive segmentation approach address lung lesion annotation problem? To address these challenges, we propose ECONet that has one convolution layer and three fully connected layers. ECONet is learned directly from user-provided interactions and hence improves over the course of multiple interactions. For efficient online training of ECONet, we extract only the patches surrounding the scribbles provided by the user and utilizing that in the training. For inference, fully connected layers are converted to convolution layer and the network is applied as a fully convolutional network to infer likelihood for lung lesions for the whole volume. The user interactions in the form of scribbles may suffer from large imbalance. In addition, this imbalance distribution may vary depending on the number of interactions and the focus of user onto multiple labels during the course of interaction. In addition, from prior knowledge, we know that lung lesions may only occupy a small subset of the whole volume in CT image. To address this imbalance problem, we propose Scribble-based cross-entropy loss, which is a cross-entropy loss with weights coming from the frequency of each class labels in the scribbles. For quantitative comparison, we utilized a synthetic scribbler and compared against state-of-the-art methods, including histogram, Gaussian machine model, dynamically balanced online random forest with hard-like features, and a variant of ECONet with handcrafted hard-like features. This variant was used to show the importance of learning convolutional features in our proposed ECONet model. We compared using accuracy, online training and inference time, and the number of scribbled voxels required by a given method. As can be seen from the table, ECONet outperforms all existing methods in terms of accuracy as well as the synthetic scribbles required. In terms of timing, it lags behind the existing methods where those methods do not perform as good as ECONet in terms of their accuracy. For qualitative comparison, we utilized scribbles from non-expert annotators and applied using ECONet and comparison methods to achieve relevant annotations. As can be seen, ECONet annotations are much closer to the ground truth, whereas the comparison methods they suffer from over and under segmentation problems. ECONet is implemented using MIDL, and the sample app is shown here, where the user provides scribble interactions and perform updates using the ECONet model. We showed the appearance ambiguity of lung lesions in CT volumes. We also showed limitations in applying existing appearance-based likelihood methods onto such datasets. Towards this end, we proposed ECONet that enabled online learning and inference of likelihood from user annotations. ECONet enabled state-of-the-art accuracy with least amount of scribbled voxels required, as shown by our synthetic evaluations. For our future work, we plan to extend ECONet to utilize output from automatic segmentation methods, as well as its application on multi-level segmentation problems. In addition, we want to apply ECONet on other datasets that may have similar appearance ambiguity. Thank you so much for listening, and I hope to see you at the conference.